We're about to uncover the latest breakthroughs in VQGAN, Rectified Flow Transformers, Adversarial Diffusion Distillation, and Latent Diffusion Models. Tune in to learn more. Hello folks, today's podcast is going to be an insightful one. We're diving deep into the world of generative models. Specifically, we're going to take a close look at four prominent methodologies: vector quantized generative adversarial networks, or VQGAN, rectified flow transformers, adversarial diffusion distillation, also known as ADD, and last but definitely not least, latent diffusion models, or LDM. These models are making significant strides in the domains of image and video synthesis through unique approaches and improvements. So let's dive in. Over to you, Evo. Can you get us started with an overview of VQGAN?
Absolutely, Mark. So, VQGAN is an interesting hybrid model that brings together vector quantization and generative adversarial networks to produce high-quality images. It uses a method known as codebook to represent various visual parts of an image, which are then utilized by a transformer to create the final output. This approach was pretty well articulated by Miranda in 2021.
That truly sounds fascinating. The architecture is quite unique, isn't it? Could you elaborate a little bit on that?
Why, sure. The VQGAN's architecture primarily consists of two key components, namely the VQVAE encoder and the GAN. The encoder compresses the input image into a bunch of discrete tokens or embedding vectors, thereby reducing the dimensionality of the input pixel space. These tokens are subsequently fed into a GAN to bring forth the final image.
Wow, the methodology is quite intriguing. Now, moving on to its applications, where exactly has VQGAN proven to be effective?
Well, VQGAN has shown superb results in text-to-image synthesis and image-to-image translation. Its unique feature of learning both the visual parts of an image and their relationships empowers it to generate high-quality images. Indeed, it's a game-changer in the image synthesis domain.
Incredible. It's really inspiring to see how these technologies are shaping the future of image synthesis. Now, let's switch gears a bit and talk about the rectified flow transformers. Can you give us an overview of this methodology, Evo?
Of course, Mark. The rectified flow is yet another innovative generative model that essentially connects data and noise in a straight line. This approach simplifies the whole concept in comparison to traditional diffusion models. Not only that, but it has also demonstrated superior performance in high-resolution text-to-image synthesis.
Fascinating. It's really amazing how such complex technologies can be applied in such user-friendly manners. So what can you tell us about its architecture?
Well, the rectified flow transformers employ an entirely new transformer-based architecture designed for text-to-image generation. This architecture has separate weights for both the modalities, text and image, thus allowing a bidirectional data flow. Needless to say, this significantly enhances the efficiency of image generation.